Hi everyone. So today we are solving this problem, undirected graph. Undirected graph. So in this we have given edges 0, 1, 0, 2, 1, 2, 2, 3, and we have to find, is there a cycle in this graph? Is there a cycle in this graph? So let's start. First let's create our adjacent list. So the common fit. So from 0 we can go to 2 and we can go to 1. Okay, so 1 comma 2, then from 1 we can move to 0, we can move to 2 as well. From 2 we can reach 1, we can reach 0, and we can reach 3. Okay, and from 3 we can reach 2. So this is our adjacent list. Now we have to find a cycle in this graph. Cycle means that, for example, we can start from 0, we will go to 2, from 1 set 1 to 2, then 2 to again 0, which means their cycle exists. Okay, so this we have to find. And how are we going to do this? So let's suppose that you can reach from 0 to 1, okay, and 1 to 2. So when you moving from 1 to 2, the parent of 2 is 1. Parent of 2 is 1. So if you find a neighbor of 2 is 0, which means that what? Even though your parent is 1, from which means that you can reach 2 from 1 from 2, there's a value or neighbor where you can again reaching 2 again as well. Again 2. Simple means that neighbor should not be NGH, your neighbor not equals to parent. अगर ये कंडीशन मैट होती है हमारे यहाँ पे, और यहाँ पे हमारा पेरेंट कौन है? जब हम when we are moving from 1 to 2, our parent is, the parent of 2 is 1. Okay, but when we check the adjacent values or neighbors of the 2, we find that again the 0 exists, which means that it is saying that we can move to 0 and then again we will reach 1 again, which is, it is indicating that there is a cycle, and we have to return true. Okay, so let's dry run this code first. So let's start. So let's again create our adjacent list. So 0, from 0 we can reach 1, 2. From 1 we can reach 0, 2. From 2 we can reach 1, 2, 0, and from 3 we can reach only 2. This is our adjacent list. Okay, now we need a we will do here bit first search, BFS algorithm. So we will create our queue here. Okay, now here, and yeah, so all these things are done. The variables which we need is adjacent list and our queue. Everything is done. Now let's move to our solution. So here we need to track two things. First is a node, so we'll put a node here, value which is 0, and the parent. Okay, but for now, for initial case we will put -1 because we are just starting our loop, so there is no parent for now, at least for us. Okay, so 0, -1. Let me clear it once more. 0, -1. Okay, now let's start from here. Our loop will run, okay, from while loop. So we'll take out this value 0, 1. So node is what? 0. Parent is -1. It is not exist. We already visited 0, so we will make 0, 2. Okay, now let's check the neighbors of 0. So we have this 1 comma 2. So 1 is going to be our node and 0 is going to be our parent, because we can reach 0 to 1. Okay, then we'll reach 2. It is not visited. We'll make 1 2, and 2 is also visited. T here. We'll move 2 comma 0 as well. Okay, now the values of this are done. Okay, now let's move. Now let's take out the 1 comma 0. So here, instead of node, we have node is 1, parent is 0. Okay, now let's check the node 1 neighbors. These are the neighbors 0 comma 2. 0 is already visited, it is true, and its parent should not be equal to neighbor. So its neighbor, current neighbor is what, which we are checking. Its neighbor is 0. So it is equal to parent, right? So we'll not return true, we'll just move out. Then after this, we'll change this and we'll move to this value, which is 2. Now it is 2, the neighbor of 1, the neighbor of 1. It is already visited, so we'll check our next condition. Is neighbor is not equal to parent? Yes. Neighbor is not equal to parents, which means we will return true here. What is saying that we can reach 0 to 2 again, and from 0 we are already reaching 1, correct? This is what we checked previous case, that from 0 we are reaching 1 already. That is why parent of 1 0 1 is 0. The parent of 1 is 0, right? Now from 0, if we are again reaching 2, if we are again reaching 2, which means there is a cycle exist. Okay, so let's do it one more time. Okay, let's do it one more time. Let's start. We will put our initial value just to run the initialize our BFS algorithm. 0 comma minus 1. Okay, we'll make 0 true because we have visited it. Okay, now we'll pop the 0 comma minus 1 out. 0 minus 1 node parent. Okay, now let's check the neighbor of, 0. Okay, node 0. So we have 1 here. It is not equal to parent and it is not visited yet either, so we'll make it true. Now check second neighbor, which is 2. So it is 2, not equals to parent, and it is not visited also. So let make it visited, true. Now also we have to put in the queue, our queue as well. So 0 comma 1 first child, sorry, not 0 comma 1, 1 comma 0. 1 is node, 0 is parent, then 2 is node, 0 is parent. Okay, okay, now 2, we'll make true. Now all these values are done. Let's, now we'll pop the 1 comma 0 out. So 1 comma 0, 1 is node, 0 is parent. Now let's check the neighbors of 1. Is this first is 0, so it is already visited. We'll check our second condition. Is it equals, not equals to parent, but they are equals to, so it is okay, there is no cycle right now. Now let's check from 0. We'll move to second neighbor, which is 2. Now neighbor is 2. 2 is already visited. Here 2 is already visited. Neighbor is, which means it is true, it is already visited. Now we'll check our second condition. Is not equals to parent? Yes, it is not equals to parent, which means their cycle exists and we will return true. Okay, so now let's write our code. So let's start. First, our adjacent list. So our array for I in range based on vertices we have, then for u comma v in adjacent list u dot append v. And now because we are doing the undirected graph, we have to same from 0 to 1 we can reach 1, so 1 to 0 again we can reach 0, correct? So adjacent list v dot append u. And what is this part which we understand right in our logic? So let's check, I will show you. So the adjacent list which we created here, this part is our, which we just written our code. Okay, so now let's again move to code. After adjacent list, let's create our visited array. Visited array v. Okay, now let's call our bfs function for I in range v vertices if not visited, then if bfs return true, which means there is a cycle exists, we will also return true here. Else at the end of the our code will return false, there is no cycle we find. Now let's write our bfs function def bfs our start node. Okay, now let's put in our queue. So dq our start node in tuple, which we are doing that just to initialize our breadth for search algorithm. So start node comma -1. Okay, so just to initialize our loop, then make it visited start node true, then while q node comma parent, let's pop this out, the first value, pop left, then write our while loop again. Now let's check our neighbor. It's time to check our neighbor in adjacent list. So we have node. Now if not visited, not node, actually our neighbor, if not visited, so we will make visited neighbor to q dot append. Let's add NGS neighbor is our next node and the current node is our parent. Okay, now another condition, our second condition, elif, if neighbor not equals to parent, then return true, which means there is a cycle exists. Okay, else in our final condition just simply return true. And of course we have to import the collection from collection as well. It is already imported, so let's run this, and we have some error. Okay, so there are some variable mistakes. I didn't start node, it is actually a node, start node. This one. Okay. Is there any other spelling mistake we done? NIG POR. Okay, here it is again. Something is wrong. Okay. Then tuple visited true, correct. While q not comma parent q spelling is correct. For neighbor in adjacent list, if not visited neighbor q dot append. Yes, here we should return false, not true. I think everything is right. Now let's run this. Okay, now it is working. Let's submit this. And again we have some wrong answer, which means we are doing something wrong again. Let's see. For I in range u edges adjacent list u comma v in edges. Correct v append u correct. Visited true. Then our pfs function. Tag pfs start node q start tag and the start node -1. While q node and parent for neighboring adjacent node, if not visited node equals to lf true, then return false. Again here should again false, written true. Let's submit it. And yes, now it is working fine.